Hey there! Welcome to the second exercise. This time we'll be simulating a viscous liquid falling on the ice cream, okay? All over the ice cream. Sounds delicious, right? Okay, let's start with real flow. First, we are going to undock the panel and dock it here. Create a new scene, and as always, uncheck the display icon box. What we are going to do now is link an emitter to Spline, something similar to what we do in Cinema 4D. Let's create a circle and place it at the top of the ice cream. There, more or less. Then reduce its size considerably. Okay. Now we're going to make the spline. How? Well, just select the circle shape. In the right panel, change the plane of the spline, this new circle, and put it in the XZ plane. Then move it upwards. Okay. And this circle will be the guide for the emitter. Let's click on the emitter in the scene tree and press Align to Spline to align the emitter to the spline. Perfect. Now we're going to drag the circle from the scene tree to the spline path parameter in the tag properties. This way, we can animate the liquid and tell the emitter to follow the spline path until reaching 100%, which is the end of the path. Let's make it smaller. And now we're going to do the same and create another circle. To do so, we just need to duplicate the spline. That's it. And then a new circle is added, which we are going to do a little bigger. Then create another emitter. Again, go to the scene tree and select Align to Spline. Drag it to the spline path field. Select the emitter and make it smaller. Guys, select the new spline and rotate it so that they don't begin at the same time. Let's put it here, okay. Okay, guys, I think we are ready to do our first animation. This way we can check how the liquid flows out downwards. However, we need to add a collision tag. To do so, right-click on the ice cream group and select Collider tag. Great. And now we're going to do a small animation of the emitters. We are going to begin in the keyframe 0, position at 0, and move the time indicator to the keyframe 120, and change the position to 100%. This way the spline will go around the entire circle. Click again on position. If the simulation runs too fast, add some keyframes to 150. Now select this keyframe and bring it to the end, to the keyframe 140. Okay. Okay, let's do the same with the other emitter. So our simulation is ready. We've simulated this kind of liquid falling down and turning around. Now what? That's it! A demon gravity. We're also going to add a demon KH to control the animations and establish some limits. Set life parameter to 5, kind of, and have a look at the animation. Don't know. Not sure. I think I'm going to lower it to 3. Well, I think 2 is fine. And guys, don't forget to save the scene. Once it's saved, we are going to activate the measure to see how the liquid falls and looks, okay? As you can observe, the fluid is too liquid and we wanted it to be more viscous. So, go to Fluid and in Type here, select a different type of liquid. Viscoelastic, for instance. Now it emits out differently. The fluid is far more viscous, right? The next step will be playing around with the different parameters to achieve a good result. Before that, we need to create the material. I've already created this material, which is of a single color. Okay, have a look at this window. It has noise with these 2 colors. Okay, and the 2 colors. And I've selected the wavy turbulence noise. So I've created one layer for the noise and a gradient effect. These are the colors I've chosen, white and red. I've selected the 2DU gradient type. Remember to add a little bit of turbulence here. Then make sure you select the option Hard Light for the gradient to get this effect. I've kept the rest of the default parameters. Okay, once the material is created, we are going to add it to the fluid by dragging the material. This way our fluid will look like a sort of strawberry and cream syrup. Let's cache a simulation. Well, the liquid looks great, right? Delicious. In order to simulate the liquid, we just need to tweak the measure and fluid's properties. Here, in Fluid, we're going to blow up the resolution to 3 and reduce the internal pressure considerably to 0.250. Then increase the external pressure and reduce the tensile. Right after, we find some important parameters, which are the viscosity or the cohesion, determining the liquid's compactness. However, for the moment, we are going to move the viscosity slider to the middle, more or less, and increase the cohesion. Well, let's reduce viscosity a bit more, like here, and also the elasticity. Then increase the damping, more or less here. Okay, let's check it out. Don't forget to go to Scene and remove the cache simulation. Okay, let's increase the kh a little bit because the fluid is more viscous and the simulation is lower. Okay, let's see if we can see it. Perfect. Well, remove the previous cache simulation and do a new one. Perfect. The liquid is much more viscous now and seems more like a topping or something like that. I just tweak the parameters to get this effect. It only remains to increase the measure and modify the emitters. So go to the scene and remove cache. Okay, and let's modify the emitters. Right now we have two circles, but due to the fluid we are working with, perhaps a triangle shape would be more appropriate. But this is the only parameter we are going to modify. Click on the other one and do the same. Okay, let's move on to the measure. We need to increase the resolution, although, as I told you, the only problem is that it slows down the process. That's why I'm going to select a low resolution for the moment. Increase the radius and set a smooth at 3. Okay, reduce thinning to 0.5. Great. Well, you'll see that the result is much better because the liquid falls down in certain areas, like this one, in this area, it breaks. But I think this effect is realistic and it breaks since the fluid is viscous. See? This is the effect we are looking for. As you know, we can modify it in the Fluid Properties panel. We can change the viscosity, cohesion, elasticity, and so on, which are really important parameters. There's another option that we are going to use, and that's also really important, which is the Demon Sheeter. This one is great for filling the holes generated in the fluid. So select it and then tweak some parameters. Set minimum cavity size to 0.95. And then uncheck the option Use Velocity Alignment. Don't touch anything else. And let's have a look at the result. Okay, fine. The result is even better now, obviously. Later on, we can increase the measure level if we want to. Do you remember the collider option? I think it's also a useful option in this case, where we can increase the friction value in order for the liquid to collide with the ice cream and it doesn't fall down. Okay? So we're going to set it at, 0.05, for example. And then cache a simulation again. Great. We can also modify the spline size to make the liquid fall in a different area if we want to. But I think that we don't need to modify anything else. Well, yeah, let's increase the measure's resolution now. I think a medium resolution is fine and reduce radius to 9. The next step would be inserting some cameras in order to simulate an animation from different perspectives. To do so, just go and click on Add Camera Object and then press to this small icon. I'm going to insert different cameras. Okay, another one here. So that each part of the animation is shown by different cameras. And now we're going to see the final result. So here we have the animation, okay? It's already exported and I've included the background. As you can see, it's the same animation but from different perspectives. It could work for an advertisement, for example. It's up to you, the cameras you use and the colors you apply. Our main goal is to add a viscous effect to the liquid so that it looks like a kind of, I don't know, syrup or something like that. Well, guys, are you ready for the last exercise? See you there!